Good afternoon, ladies and gentlemen. I will be your chair for this session. Welcome to what I think is the last session for the day. Just a few house rules for the session. Please just ensure that your mics are muted for the session. And then also you will see there is a chat box on Zoom, and this is for general comments regarding the speaker. And then we also have a Q&A where we please ask that you post your questions. And then yeah, you can also upvote questions that are already existing. Right, so for this afternoon session, the first session will be by Dr. Bianca Peterson. She's currently a postdoctoral research associate at the Center of Excellence for Pharmaceutical Sciences at the Northwest University of Potchefstroom. And Bianca will be talking about the Co-Data RDA Data Summer School, the annual event for early career researchers that was held recently at the University of Pretoria. So I'm going to hand over to you, Bianca. Thank you. We're looking forward.
I just want to know, okay, so Lauren says I can switch on my video. Okay, here we go. So yes, I'm Bianca Peterson. As Isak mentioned, I'm currently a postdoc at the PharmaCen, so the Research Center for Pharmaceutical Sciences at the Northwest University. But I'm also a director and trainer of my own company, and it's called Conquest Analytics and Training. And but I want to talk about the Co-Data RDA schools. So just to give a bit of background before I get into that, during my postgraduate studies, I had to deal with big data and I didn't know how to analyze my own data. And somebody suggested that I attend a software carpentry workshop. It's for 2 days. And that helped me to get started with the data science skills. I then went on to attend the very first Co-Data RDA data school in Trieste, Italy in 2016 to expand my data science skills. And the year after that, I volunteered to return as a helper for the next summer school. And this year I co-organized and co-taught at the first South African summer school that was hosted in Pretoria in January. So the Co-Data RDA schools changed my life and my career path. And I'm hoping that my talk will be of interest to those of you who need to learn how to analyze big data, but don't yet know how to do that or where to start. So without further ado, I'm just going to share my screen with my presentation. Let me just get that, sorry. I seem to have closed it during the testing session. There we go. Okay, you should be seeing my full screen now. So there is currently a major core data science skills gap in Africa since postgraduates do not have access to foundational data science and open research training. Although training material is available online or with instruction, it varies between short intensive courses or semester-long courses, which are usually domain-specific and focused on specific skills. And we feel that introductory level data science training is essential for all research disciplines, and it's part of digital literacy. Collaboration between various stakeholders are needed to gain a holistic view of what is needed as foundational training, but this creates too many issues to develop this from scratch. So this is where the Co-Data RDA initiative comes in. Co-Data and RDA are leading international organizations aiming to facilitate research data sharing and accessibility. And they have developed a program of short courses that stretch over 2 weeks to provide young researchers with core skills to enable them to work more effectively and efficiently with their data. And their primary goal is to teach foundational data science skills to early career researchers in low to middle income countries, while also regionalizing training capacity by growing a community of alumni, instructors, classroom helpers, and hosting institutions. So the curriculum, as I said, it stretches over 2 weeks, and it consists of several courses. And we currently have two strands, the data science strand and the data stewardship strand. So the first few courses overlap between the two strands. And these include Introduction to Unix Shell, which you would need to work on a cluster such as the CHPC, Git for version control, programming for analysis, either using R or Python, research data management, open and responsible science citizenship, and information security. The data science strand then moves on to machine learning, neural networks, and computational infrastructure, where we really focus on working in the cloud or with clusters such as the CHPC, whereas the data stewardship strand moves on to advanced research data management topics. So I would really encourage early career researchers to attend such a summer school as soon as possible when you get data. So the introductory level data science training is applicable to all research disciplines. So it doesn't matter if you're a social scientist or a physicist, it doesn't matter, it applies to all of you. And you also get the opportunities to make connections, friendships, and lasting collaborations. And the alumni network provides post-school peer support and establishment of new schools. And by using regional trainers, the cost of the events is reduced a lot. And it allows the local hosting institutions to run more training events per year. So this map shows you where the previous schools have been run and in which years it has been run. And as you can see, the Trieste event is repeated annually. It started in 2016. And you can see we've only had one school in South Africa, which was hosted in Pretoria this year. In total, over 400 students from 40 different countries have been taught, and this has added up to over 500,000 of free instruction. And so the instructors that teach at these schools are volunteers, they don't get paid. And many students come back later as helpers or instructors, which is what I've done. And I'm currently also a co-chair for the CoData RDA working group, where I help them to co-organize schools across the world. But I also like to still do the training myself. So we identified the standardized curriculum of the CoData RDA research data science schools to be suitable for our context in Africa, because it exists already, it's tried and proven, and it saved a lot of time when compared to having developed everything from scratch. The curriculum was there already. We could tap into the alumni network to find helpers and instructors. So that really saved a lot of time. The training is rolled out to the international community, and the alumni network that is linked to this initiative allows the candidates to immediately be part of a professional network. And of course, also exposure to peers from different disciplines creates shared jargon and experience that will show impact in future, because everything in life really is multidisciplinary. So I created these two figures when we did the South African summer school this year. So the figure on the left shows the ratio of female to male participants. It was roughly 50-50. We had a few single participants from some of the countries, and in total, we had representation from 13 countries, as you can see on the map to the right. So for the way forward, our vision is to fast track research data science skills across Africa by running regional schools. And we aim for far transfer, meaning that the people who attend these schools, we want them to take the skills that they've learned back home and teach the others there, you know, host regional schools. We want the skills to be transferred beyond the classroom. From now on, we will be hosting Train the Trainer events. We've had our first one in August. Unfortunately, we had to do this online. We could not do the in-person event. And these events will be used to grow regional skills capacity. So if you have attended a summer school and you're part of the alumni network, you can come back to the Train the Trainer event, and we will teach pedagogy skills. It's important for us that our instructors not only know the material that they want to teach, but also know how to teach the material. And it's based on this teach one concept. So if you learn something new, you go back home, you teach one other person, and then that person can teach one other person. In that way, you grow regional skills capacity. The curriculum that we're currently using is endorsed, and of course, it will evolve over time as needs change for researchers. And the network is ever expanding. We are adapting to online solutions, and we are trying to find partners with similar vision. If you're interested to learn more, please visit the CoData RDA Data Schools website that is linked on the slide. You will find information about past and upcoming schools. The materials are also linked on the website. As we said, everything is open, it's free. You are more than welcome to go through the material yourself, but I have found that instruction together with the materials really works best. You'll also find some tips on how to reproduce the school. So if you're interested in hosting a school like this back home, please get in touch with us, look through the website for some tips to see what you would need. And of course, once you have attended a summer school and you're part of the alumni network, you can volunteer to become a helper or instructor in future schools. And then we've been working on an interactive world map of the alumni, specifically Rob Quick. He's also one of the co-chairs on the group, and he's been working on this amazing map, and it's coming in about 2 weeks' time. And then you will be able to see the alumni spread across the world, and you can get in touch with the alumni close by, and they can help you to co-organize regional schools. So we are currently planning an online summer school, and we've decided the dates to be 3rd of May until 9th of July. I'm also providing the link to the website. And the format will be different from what we usually do. So usually it's a 2-week summer school that goes from Monday to Friday. But for this online summer school, we will be covering one topic per week. And so this will then stretch over 10 weeks to cover the 10 topics that we have. The current deadline for applications is the 29th of January, 2021. Registrations are not yet open. We are hoping to open it soon. We are just still busy setting up the conferencing tool for the registrations. So if need be, we will probably extend the deadline to give you more time to apply. And if you have any questions or you want to find out more information, if you don't find it on our website, feel free to contact us at summerschoolpretoria@gmail.com. So that's really just a short overview of the schools, and we would like to thank all the conference sponsors for their generous support. Thank you. That's all from me. So any questions?
Great. Thank you, Bianca, for that presentation. I know the massive contribution that you're making towards the community. I can allow some questions now. I'm not seeing any questions for Bianca. If not immediately, you are more than welcome to send it to her with the email address that she mentioned. I would just like to, we have some time, Bianca, just like to follow up with you. Just 2 questions that I have. The one is, you know, are you to some extent tracking participation, or, you know, if someone went through the summer school, are you tracking them in terms of, are they doing refresher courses, or, you know, do you basically walk the path with them? Are you doing that?
So the idea with the alumni network now is we've established some task groups or working groups, and there's one specifically for the alumni, and I think Louise Seidenhout is in charge of that group. She's also one of the co-chairs, and the idea is to then do webinars or refresher sessions continuously, because we haven't done that previously. We have relied on the fact that the alumni as a network, they will keep in contact with each other and support each other. And back home, if you have colleagues that work with the same tools, you can maybe ask them for help as well. But we've decided to establish these working groups. And I'm in charge of the Train the Trainer working group, although I still need to do a lot of work there. We've only tried out the online Train the Trainer event this year for the first time. But we would like to run these events every year at Trieste, which will be our base for these events. But the idea is to really grow regional skills capacity across Africa, and, you know, get alumni everywhere, and then host these events at a low cost. so that we can build skills capacity across Africa. Because there's a lot of organizations fighting to get data open, and that can really reduce the gap between low and middle income countries versus high income countries. Because if the data is available, we can do the work, but we can only do the work if we have the skills. So we are trying to address that gap.
Great, thanks for that. And then the last question was your curriculum. How often is that reviewed for relevancy?
Sure. I'm not sure who reviews the curriculum, but the instructors that we have, most of them are lecturers, like professors at universities. And I see Marty just made a comment there. It's reviewed annually. Thank you, Marty. So we are trying to keep up to date with the tools as they advance or change or update. And of course, the curriculum has been adapted already. Initially, we started only with the data science strand, which we later, and initially we didn't have information security as a module. It was SQL. Then we decided to replace SQL with information security because we felt there was a need for that. And then later on, we developed the data stewardship strand because once again, we became aware that there was a need for that, especially for librarians, to be able to also help researchers with training events. Yeah, so the curriculum is evolving over time as needs change.
Perfect. Thank you so much, Bianca. I really appreciate it. Right, that was then Dr. Bianca Peterson. I'm going to switch over now and allow our next presenter. Thank you very much, Bianca. We really appreciate your time. And any questions can be forwarded to her later on. Right, so the next speaker is Mr. Boniface Akuku, who is the Director of Information and Communications Technology at the Kenya Agricultural and Livestock Research Organization. He is also chair of the Co-Data Agricultural Task Group, and he is going to be talking to us about sustainable management of remotely sensed Earth observation data, and a case specifically for high-performing computing and big data platform development in Kenya. I'm going to hand over to you, Mr. Akuku. We look forward to your presentation.
Thank you, Isaac. I hope you can hear me.
Yes, we can hear you.
Okay, thank you. I'm just putting my screen on. Okay, so I'll talk about sustainable management of remote sensed Earth observation data. And this is a case study for high HPC and big data platform development in Kenya. So on the introduction, I would say that there's a lot of pressure to manage and utilize valuable data to impact on agricultural productivity and to increase. And however, several challenges exist. This is also seen that there's fast growing population and agricultural development has a lot of constraints. Basically just expand the problem in a period where we have environmental vulnerabilities. Now, we see that some of these challenges could be solved by remotely sensed observation data, and particularly with the availability of high-performing computing and the freely, openly accessible repositories, which remains a challenge. Again, we also find that technical capacity to exploit big data opportunities and technologies also lacks in Kenya. That's the area of the study, basically just showing different counties in Kenya. So this is just showing some of the constraints agricultural development that Earth observation data using high-performing computing and big data platform can basically be able to address. We have issues of biotic and abiotic stresses. We have areas on pure mechanizations, and we have limited range of products which are not available, and also markets is unorganized. This has led to limited use of technology, agricultural technologies, and poor pre-harvest and post-harvest handling. So on the production, we have a lot of challenges and climate change, pest and disease, low productivity, land fragmentation and soil health. On the input, we have a lot of challenges on narrow technology horizon, low yielding varieties, limited extension services. price volatility. On the post-harvest and processing, we also have a lot of challenges of post and pre-harvest losses. There's also poor handling and inappropriate storage, leading to losses. There's lack of aggregation centers, and there's also limited mechanization. On the market, we have poor access to market. We have issues in regulatory policy issues. We have volatility of prices and also low diversity. So these challenges are actually affecting the Kenya agriculture, and we want to see how high-performing computing and big data can address these challenges. Now, to date, we found that many organizations have not realized the potential of Earth observation data as much as freely available, and even the openly available Earth observation data are not properly utilized. This is because the challenge is complexity, particularly in the case of volume and processing capabilities of Earth observation data. So in this regard, data cube technology, which is a new paradigm, can help organizations to realize the potential of Earth observation data by lowering the barriers. For instance, it can help us provide access to extensive data, which is in an analysis-ready form, which also in a short while. So I'll explain about the Kenya Data Cube platform as a case study, and particularly its integration with the high-performing computing. So last year, Kenya acquired its first high-performing computing and big data platform, and we are trying to use the Earth observation data to be able to address some of the challenges I mentioned earlier. So the first thing I want to say is that Data Cube has enabled us to transform Earth observation data into analysis-ready form, because one of the problems is to analyze or to transform Earth observation data into analysis-ready format. And this affects not only Kenya, but many other developing countries. So the other challenge is that the decision makers must invest in HPC and related technology, such as big data, because once you have investment, you can see, we're going to show you how we've been able to address some of these areas. So the investment will enable researchers and universities to use and explore and generate new insight using advanced technologies like algorithms, and to extract insight which can address the challenges facing agricultural productivity in developing countries. So why HPC and big data for Kenya agriculture? Why did we take this dimension? Why did we invest in HPC and big data platform? This is because that it has helped us to digitize, and by digitizing our data, we are able to get reliable and accurate data that can help us see how we can address some of this. So one of the problems that crop growing is not easy to interpret. We have yield gaps, and therefore you need to observe data, collect data over a period of time. We have also found this challenge that the current databases that we have are static and heterogeneous. So access and exchange is difficult. Then validating data over multiple growing seasons also takes time and resources. And therefore, as we said earlier, the complexity of analyzing the value chain for every crop is also very difficult and problematic. So this is why we decided to invest in big data and high-performing computing. Now, the framework we develop is where we bring in different stakeholders together: researchers, the finance industry, the agribusiness, agronomists, and policymakers. And that's how to sustainably manage remote research data, because you need different players, researchers, how to transform this data into analysis ready, and also policymaker to get policy brief that they can make quick decisions. So in this case, the architecture is that to develop a platform that is actually data-driven architecture. So in this case, Calro, we work for, we have built a foundation for data management that's sustainable, in the sense that they design how do we process that data, and how do we empower the people that are supposed to make sense or make decisions from that data using ICT, and how do we streamline the process and have strategies. So to do so, you need a flexible and dynamic IT environment. You need to streamline the processes and the strategies, and we need to integrate ICT into daily routines. And that help us, what we build is what we call future-ready infrastructure, which can help us analyze this data in future. So this is an example of analysis-ready data. So what happens is that you get data from the satellite, that's the remotely sensed Earth observation data, from Landsat 8 and Landsat 7. Then using algorithms, you transform that data into data cubes, which is compressing that data. And once you compress that data using the Open Data Cube infrastructure, then it becomes analysis ready. To do so, we use a number of tools and applications. There are open source libraries that help us to do that, and you'll see the results of this. Now, the focus is to create analysis ready data at a national level, because the data, as I said, that come from satellite or remotely Earth observation data is not easy to analyze. So the approach helps us to make it in analysis ready form. So you take the surface data and then you analyze them either Sentinel data or Landsat data. And then once you get this product, you also get historical data which you can add to the current data sets, and you transform them to a data cube, which is a framework that can help us to analyze this data in a very easy way, as I would say. So in the next slide. Now, so in terms of results, so once you transform the data, you can never be able to build applications that can enable you now to access that data through APIs or through a web interface. So we create a website like what I'm showing in the front, which now help you now just to extract that data, and you can now use it for many other tools or applications. Now, for example, when we wanted to do map what called crop phenology, which help decision making, we use NDVI and the algorithm for NDVI, where we now pick the data, analyze the data using NDVI, and that helps us to map the phenology. So for example, you can analyze the vegetative index for different crops yearly over time. And for 2017, whichever year, you can be able to go back as many years as possible. And that helps you now to see how has that land been changing over time, and how has that crop been changing over time. So you can identify a small area or any area and then do analysis index over time. You can also assess the different agricultural farms over time. For example, you are accessing farms for Kennedy, farms for Jobian, and farms for Vincent. And you can see changes in those farms over time, and you can see the potential on those farms, and then that can help you optimize this on what to plant, on when to apply fertilizer, on what not to plant, and what to do. So you can also assess land use change and crop classification. You can see how has the use of the land has been changing over time, and that can help you classify crops on what is to grow. And therefore, this you can have accurate and reliable data, which can help improve food security and resilience of farmers. Because if a particular land, assessing the land use can tell you whether you need to continue planting a particular crop or to change the method you've been applying, and that can help resilience and food security. It also helps to monitor the progress of the agricultural productivity, which also leads to achievement of UN Sustainable Development Goals. One of them is to reduce hunger. So when we improve the resilience and food security of farmers, we are able to achieve some of the UN Sustainable Development Goals. So, to do so, Earth observation data can be used to build models, which can help in monitoring how the crop is performing, how the land is performing, the different agricultural practices, and this can increase productivity of smallholder farmers. And this can also enhance policy, because policy can now be able to make decisions based on evidence and on what are the technical interventions that the farmers, smallholder farmers require so that they can improve their productivity. Now, this is only possible by the use of high-performing computing resources and big data technologies, because as I said earlier, other databases are static and heterogeneous. They are not able to analyze or transform Earth observation data into analysis-ready format. They're not able to transform the data to be able to be scalable and to be applied in different applications. at very high granularity. Now, big data tools also help us, machine learning and modeling also enable classification. So you can classify the fields by crop type from the images collected during the growing season over a period of time. You can go back 10 years, 20 years, 100 years, and that helps you apply machine learning and modeling, and you can now classify the fields and crop types, and that informs what can be grown where and what should be grown where. So an example is where we collected data in the country using virtually relating to the data, and we're able now to cluster or classify the farms. This is just showing historical land, how the land has been over the years for a certain period of time, and changes that have taken place. You can see the same land. This is the same land, but you can see how it is changing over time. So by these changes, you can be able to analyze what is affecting the land and whether it is still suitable for agricultural productivity and for differentiation. We can also then triangulate this data to calculate the distances that the farmer need to move to acquire resources, or they need to move like water and other resources. So you can also calculate the distances, what we call distance matrix analysis, what distance they require to get the inputs, what the distance they need to cover to get to market, and that can also bring aggregation of market. They can also bring agro dealers closer to the farmers, and so many other factors so we can help you make decisions and policy direction. So policy can decide to waiver or do certain things. I think also it supports research and academic and also hackathon activities. With the HP resources and the big data environment that we have, we are able to share data freely and a large amount of data. And we are also able to help have enough data to organize hackathons that can also foster participation on startups. So startups can now come up after training, after knowing what enterprise, what crops to grow, what value chain you need to engage in. So again, it also promotes innovations. Scientists, researchers, engineers can export data which is derived from space-based platforms such as Landsat 8, Sentinel-1, Sentinel-2, or any other Earth observation data, and drive insight which was not before, and use other open data sets just to ensure that they are able now to make sense or drive insight from space-based platforms, which again, without HPC and without big data, we're not able to do that before. Again, we have also seen that it's been able to stimulate new multidisciplinary synergies where agricultural experts and professionals are now integrated with what's happening in the space sector. Before there was a disconnect between agriculture and the space sector, so agriculture was not actually realizing the power of using data from space sector. So this has eliminated the barrier, and this has also led us to develop what we call disruptive innovations, which is actually generating a new community of innovators. And young people that can now take this data, can take this data and can now come up with innovations like weather predictions, pest predictions, surveillance, and monitoring of crops. So in this case, what we have done is that we organized it in terms of data management, which is very important because our data is huge, so we need to see how do we manage it, how do we drive the data, how do we do data mining, how do we involve research in data. Of course, for a long time, there has been not a lot of data research, just specifically to research. And how do we create access and other data tools? Also, data science capacity, we have seen education still at different levels, training agricultural extensions, just because we now have a huge amount of data which we are now able to use to be able to conduct training. And also innovations, data applications. So we are able to apply data into innovations, where now there could be now young entrepreneurs, ICT support entrepreneurs, and integrating the different services. Now, as I said, the infrastructure was very important, and the infrastructure is where you need the HPC and you also need the big data. Now, once you have the infrastructure, you can now do a host of things. You can do data mining, you can do research, you can do application of data, you can undertake education, and you can do data mining. So this is so the infrastructure is the key. And that's why having an HPC, which you now don't, you have compute resources, you're not limited in terms of compute power, and tools from the big data is the key. And now you can apply this in many other areas. So there's some of the elements what we have just said that we have been able to address, where you can find hidden structure from data by using entity matching. You can validate what's happening. You can also process where you can find a known fact which was initially not known. You can also visualize, like you can present it in some other forms that can show meaning easily without the technicality in data and without just having numbers, figures, or value. So this is some of the power that HPC and big data are helping Kenya, and that has brought in a lot of disruption in the sector. So you could see one of the examples there is young men using their phones basically to get information which has been processed from the HPC. I think that's all I have for now. I would like to thank you, and I can take up some.
Thank you, Mr. Akuku. I really appreciate it. And thank you for sharing with us the applications in Kenya. It's really great to see how it's just advancing agriculture and how technology plays such an important role in agriculture, and not just, just one applications, but playing the part in terms of research and educating people and driving innovation. It's really insightful. Thank you very much for that. I'd just like to see if there are any questions for Mr. Akuku. If not, you can, I don't see anything in the Q&A. If you would like to just quickly ask a question as well, you can unmute your mic. Alternatively, I think we can, you can circulate questions at a later stage to him, perhaps. Any questions, any comments from anybody? Right, nothing at the moment. Thank you very much, Mr. Akuku. We really appreciate your time and the insightful presentation that you gave us. We really appreciate seeing what's happening in Kenya. Right, ladies and gentlemen, if there aren't any further questions, I'd really like to thank you for this afternoon session. I think this is the last session for the DIRISA track. I'd really like to thank you for your participation in what's obviously an interesting setup for us for this year, doing everything virtually. And then you must have a fantastic afternoon. Thank you very much, everybody, and enjoy the rest of the afternoon. Thank you. Bye-bye.